Okay. Let me, I'll just share the screen and let me figure that out. Okay. So let's get that running. Okay. Hi, I'm Kevin. Some decades of coding and started doing Android before the G1. We do a bunch of community stuff. If you ever heard of DroidCon in New York, kind of involved in that. TouchLab is a company I'm partner at. We are a mobile company around for about a decade. We are kind of building a new product line around multi-platform, and that's basically what I've been involved in for the last couple of years, really. First partners out of the gate really were Square. Frankly, a lot of the stuff that we build open source, if you like it, you should thank Square because they're making it possible for us to do that. Shout out Jesse, Alec, Eric. Now Jake's back in the team. So interesting times. So I wrote this talk originally for Kotlin Conf last year, and the feedback I got was like, that's great, but that was to try to fit everything into one talk. So since I've been working on multiple versions of essentially like how do you practically approach concurrency, and another one of our partners is recently I'm doing content for Kotlin and JetBrains, trying to explain all this stuff. So when you're done with this, if it's kind of a whirlwind tour, you can go check out this hands-on and see what's going on. I'm overdoing several docs, so hopefully in the coming week, I will turn in the things I'm overdue on. So intro, when I go out and talk about this stuff a lot, I basically start with what is Kotlin Multiplatform. And this is like the concise definition. Like if I put it down into one statement, what is Kotlin Multiplatform? What differentiates it from everything else? And in here, importantly, is modern. And when I say modern, I mean not the syntax. Kotlin, the language, and the platform is modern and tries to incorporate modern things that we're learning out in the broader community. This slide is from 2018's Kotlin Conf, and Andre was talking about standard concurrency. What is that? So concurrency is hard, right? And if I wanted to explain that, that would be several talks, probably years of experience. Like concurrency is one of those things that is rare in life, which is the more you learn about it, like the more scared you are of it. Like you learn this respect as you can see how bad it can go wrong, right? So the Kotlin native model is controversial in the Kotlin community, right? People either kind of think it's a good idea or really hate it because you have to do something different than you're doing now, right? But the JVM model is controversial in a lot of other contexts, right? And by that, I mean shared access from multiple threads to the same memory. And a lot of ecosystems, JavaScript, obviously, Dart, if you're a Flutter person, but like Go, Rust, a bunch of other languages don't let you do that. And if you go out and look up, threads are evil, you'll find a lot of people saying that, but it's really shared access to the same memory in an unrestricted way that is evil. You need to understand this though. If you're going to do Kotlin native in any way beyond like a tutorial level, the libraries won't hide all the details. You're going to have to know what's going on. People have asked me, can I just learn coroutines and call it a day? And the answer is no. But, unlike my last talk, you don't need to know everything, right? You can kind of like learn the gist of it, get some practice, use the libraries, and then go on to later learn the stuff. And conceptually, it's really not hard. It's actually quite simple. So Kotlin native rules, right? There's a couple new rules. And the first rule is that mutable state can only be touched by one thread at a time, right? That is called thread confinement. If you're an Android developer, that is why you're not allowed to change the UI from a background thread. They're trying to protect against concurrency issues, right? That is enforced by the runtime. And two, immutable state can be touched by many threads, right? If you can't change the memory, then having a lot of things touch them at the same time isn't an issue. And if that's all you get from this talk, well, it's been great. See ya. Like you've got the basics, right? But it's not that simple. There's a lot more to it, obviously. But if you internalize those two things and begin to understand and think around those rules when you're implementing code, that's essentially what it means to learn how to do Kotlin native. And you start to look back at JVM stuff like this and question the wisdom, right? So like, that you're not going to change that string anywhere but the main thread. But a couple of years from now, when a junior developer starts on that side of the product and you're doing something entirely different, like they might not know that. And obviously this is an overly simplistic case, but there's a lot of places where it's not. I think we all kind of know the danger of unrestricted concurrency. So in Kotlin native, you don't do things like synchronized or volatile. You're not really directly managing concurrency, which is not entirely true because you're going to do atomics and some other stuff. But that's the gist. And the reason is like the JVM trusts you that you're going to make good choices, and native essentially does not. And again, it's not just you, it's as your team grows and things get crazy, right? At runtime, Kotlin native is attempting to verify that you're going to avoid doing bad things. And like in most reasonable situations, that you shouldn't have global state all over the place that can be mutated, that kind of thing. A lot of these are common sense things that just get tricky as you're trying to modify how you think of architecture, right? You're definitely going to have to do things differently. But there is like, I talk to people who have this sense of loss, and I'm like, you're not really losing things. There's always kind of a different way to architect it. And when there's not, you can kind of work around it. So just something to think about. I would, again, prefer if JetBrains would come out sort of with like some sort of strict memory model mode for JVM, and maybe even just in testing to get parity. And that's not necessarily out of the question. I just don't know. It's certainly not on anybody's public radar. So we'll see how that goes. And you can break all these rules, technically. It's just not a good idea. And I don't talk about it too much because you need to sort of understand everything deeply before you start breaking things. But you can, just FYI. And I, as a developer, went through what a lot of people go through, which is sort of the stages of grief where at first you really don't like this and you're struggling with it. And there's a phase where you try to get around it very early on and sort of trick the runtime. And then eventually you just kind of accept it and learn how to do well with it. And if I can have any advice, I would just say try to skip ahead to like accepting it, because trying to break the rules, especially early on, can get you into a lot of trouble. So core concepts. There is this thing called worker, and it is like the concurrency primitive that's like similar to thread, is kind of similar to executed service and handler and message queue. And my big Kotlin Conf talk, I went deep on worker, and we're not, because that's something you can look at later if you really want to go deep. The libraries will do all the stuff you need to do without doing workers, so you don't need to worry about it now. And that saved about 50 slides, so we're just going to move on. But understand that workers is kind of like thread or executed service. So mutability and state. Going back to the rule number 1, mutable state equals one thread. I've had feedback that's like, well, what about regular state? You talk about all these obscure cases. And so I'm like, okay, if you've got a simple class and you got a main function and you create an instance of that class and do stuff with it, and you don't leave threads or do anything, the state's going to do exactly what you're used to it doing, which is be mutable. You can change stuff. Nothing's going to get frozen. Nothing crazy is going to happen. So that's simple state, right? Mutable state, one thread again. You can transfer state. So you can have state in one thread that's mutable, take it out of the universe of space and time and put it into another thread. That's definitely possible. We're not going to talk about that because once you start doing this, basically nobody does this. And again, this is another early Kotlin native developer pattern that I had, and a lot of people have, where they think that this is going to be something you do a lot and try to develop clever ways to do it. It's syntactically very difficult. And in practice, you know, once you have data and you're passing it around, good practice says make it immutable anyway. And that's pretty much what everyone does. So immutable state is many threads, right? That means you can pass it around. We talked about that, but not source immutable. So if you look at this, you know, a logical Java Kotlin person is going to say, this is immutable. And that's true, but it's source immutable, right? But that's not what Kotlin native considers to be immutable. There is this thing called freeze, and freeze is a runtime immutability designation. There's a function on everything in Kotlin called freeze that you can call. And when you do it, it recursively freezes everything that object touches. It's a one-way operation. You can't unfreeze. But once you do that, data may be shared. But once you freeze, you know, it means you can't change any of that stuff anymore. So it kind of looks like this, sort of, although it actually checks everything first, then goes back up. But anyway, so that's freeze. Freeze is very important. You have to understand what that is. So crossing threads, we're going to, for the sake of this discussion, create a background function. And the background function takes a block, which has no arguments and returns nothing. That block gets run in a different thread under the hood, right? In order to do that, like we said, you have to freeze state. Blocks, lambdas are state. So to move that to another thread, you first have to freeze it, right? Then you can run it. So here is an example. We're going to have a data object, and we're going to print that out on a different thread by calling background. When we do that, we're going to freeze that block, right? Freezing that block does this. It freezes the data object, because the data object is just another piece of state that the block now captures. So if it's hard to pay attention to a remote talk and you weren't quite following everything, just super remember this slide. When you freeze a block, you freeze everything it captures. And that's going to be the source of a lot of confusion when you get started doing Kotlin native. I promise it gets easier. I don't have too much trouble with this, but I've been doing it for a couple of years, right? So let's take an example of this thing called counter model. Like we have an app, and we're going to click a button. When we click a button, it's going to increment a counter. I don't know why. That's what it does, right? So this works fine. This is a regular state. It's mutable. We're not crossing threads. But if we decide we want to save this to a database, right? Great. So you click count. We send off to the background this thing. That's going to freeze that thing. Of course, that's also going to freeze the count, which is going to be problematic. But it's even worse than that, because it's actually going to do this, because count is a field of counter model. So it's going to freeze the entire thing, right? So now we're in a weird state. So when you click count again, or counter clicked again, you're going to first see your new friend. You should definitely consider this to be friendly, because you're going to see it quite often when you first start. Invalid mutability exception. It means you're trying to change something that's frozen, and it won't let you. That is definitely a new thing for Kotlin native. Just get used to it. That's all I could say. The important point here is functions can have state. So you have to be very careful with what you capture. And this is going to be something that you just have to develop a knack for, and how to avoid it. And in this particular case, I would say you should move your background stuff to either a different function or a different class. You pass it in as a local. All you're going to do is freeze the local. Nobody has any problems. But there's multiple techniques to getting around that. So global state. Global state has some special rules. So properties, global properties, like this, can only be seen by the main thread, but they are immutable. That is like one of the weird rules. You just have to remember it and kind of get used to it. There's a long story behind it, which we're not going to get into. It's not that complicated. Global objects, by contrast, are frozen by default, but they're visible to all threads. Like this thing in here is a var, but you would not be able to change it out of the box. Okay, companion objects also are treated the same way. So you can apply thread local to either of these, and that will give every thread its own copy. But obviously, if you change some data in the main thread and you access it in the background thread, it will get a different copy of that thing. But they're both mutable. You can also say shared immutable to the global property some data. However, and that'll make it frozen and visible to all threads. You can't do that to global object, because global object is that by default. So it's kind of redundant. So this does not apply to be fully complete. This does not apply to fields that don't, properties that don't have a field backing them, like virtual properties don't have this rule. So, okay. So why special rules? The reason is there are the two rules around state, right? One thread mutable to multiple threads immutable. Global state is unique in the way that it can be accessed from anywhere at compile time without having to cross threads or be checked. So it has to essentially be born with the rules applied already. That's why. So debugging issues as you're doing concurrency. We mentioned invalid mutability exception. Again, this is your friend. It is telling you that trying to change something that is not allowed to be changed. And this is like the workhorse of the whole freezing and thread state rule architecture, right? There is criticism of this in the community that, well, hey, this happens at runtime and that's ugly. It should happen at compile time or whatever. My counter argument is that, well, yeah, sure, but there's not like there's a ton of other things that don't happen at runtime. For example, if you try to change the UI from a background thread, we're all pretty used to that. And it happens predictably. It's not like null pointer. Like it went, once you get invalid mutability exception, you're going to get it every time. So it's not like that big of a deal in practice. But it can be a big deal if you don't know why it's frozen. It's a very, very common question. So in this case, obviously this isn't hard to figure out. The first time you click it, the count will get incremented. Then it'll freeze and say to the database. And the next time you'll get that invalid mutability exception. It's not hard to figure out in this case, but in large object graphs, it can be very difficult. There is a function called ensure never frozen, and you can call this on any object. And once you do, for this case, let's say, when you click count clicked, instead of getting an exception when you try to change something, you'll get an exception when something tries to freeze this. And you can pinpoint that very quickly. And I actually, as an example, the multi-threaded coroutines was having some kind of bug. And I don't know that code at all, but I cloned it, built it, and then I put that on the place that was getting that invalid mutability exception. And it took me like 15 minutes to figure out the cause of the issue inside that humongous code base. And I still don't understand it. But it's very useful once you get used to how to debug stuff. And it could be frustrating at times once you learn the tools. It's not so bad. Which brings up a side note. The freezing operation can actually fail. So it's an interesting thing that you have to keep in mind if you're building something remotely complex. Again, in the multi-threaded coroutines, I don't think it was designed to anticipate failures when they're just passing data around behind the scenes. So there are sort of issues that related to that because you don't usually get an exception just throwing something over a thread, right? So rethinking architecture is kind of the call of the day or whatever. You really, you should be intentional with mutability, and it kind of forces you to be that way. Like but we do that now as best practice anyway. Like if you're getting data out of the database, you're not transforming it. I mean, you're not like mutating it. You're kind of transforming it in a function to create a new data graph, that kind of stuff, which is all sort of best practice. So if you're doing that kind of stuff, it's not that big of a deal. So for example, from the Joy-Con app, this is the model we had in there. There's like a content model, which sort of aggregates data and makes it something that's usable for display. There's like the platform specific view model, which does like housekeeping and lifecycle stuff. Both of those things are kept in the main thread, and they're ensure never frozen. They will never be frozen on purpose because you don't need to touch them from background threads. And then everything else just kind of comes in off of a data thread, listens to the database changes, you get the stuff from the network, all that's frozen. But once you get into this like last mile, everything is unfrozen on purpose. And we just sort of maintain those rules. I actually did the version of Coin for multi-platform, and we kind of internalize a lot of this stuff. Like all the stuff happens in the main thread as far as injecting, and it doesn't freeze anything unless you want to freeze it, that kind of stuff. But I didn't have time to really talk about that for this talk. So anyway, this can get weird. There are subtle things that you're going to have to be aware of, and it's not all perfect. Like some of this is like, well, I don't understand what's going on. So we have this thing called CampKit, which is sort of the starter project that we give out to people. I'll talk about that later. We inject some stuff, including database helper and settings. And then we launch a flow from SQLite. So that's a lot of code for a slide. I'll just highlight this. The key point here is that map is a function that gets run on another thread. And just like anything else on another thread, it's going to pass that block and freeze it and do some stuff. And this is fine. But if I take that injected settings and try to do something to it, this will fail. Why will this fail? Because we can call ensure never frozen on breed model just in case to make sure we don't freeze it in the course of our development changes. But capturing settings will cause the parent to be frozen. And it's like a subtle thing that you just kind of have to get used to. It is like weird enough that I basically threw away my January writing an IntelliJ plugin that tries to tell you when you're doing things you shouldn't do, right? So in that same code, it marks as an error. You hold the cursor over it, and it'll tell you like, hey, this is probably going to freeze breed model. Breed model calls ensure never frozen. You probably don't want to do that. We did not release this yet. It's kind of, there's a lot in it. And once you get used to doing this stuff, it's not so bad. We might release this. I don't know. We have to sort of poll the community and see what happens. But there's a lot more work left to do. It's very unpolished. Anyway, confusing topic. This can be frustrating. But the other side of that frustration is an opportunity to like think about what the JVM's doing. Like a lot of the stuff that we do in the JVM, we do because you can, but it's not necessarily like you should, right? So the problem here is that we're injecting, these objects that globally, and we're calling multiple threads from within the same code base. It's very unconcerned with what might happen, right? So in this case, like maybe that settings is just calling into shared preferences, right? But maybe a colleague a year from now decides that they should really cache stuff in settings in memory because that's going to speed things up, and they don't design it to be from multiple threads. And then you got a fun problem, right? The JVM is going to let you do that. Kotlin Native is designed to not let you do that. And I think it's definitely stories coming out, and ourselves included, of situations you find where like it really makes you think that maybe we shouldn't be doing that, or this needs to be much safer and by design. So, okay, enough preaching. Concurrent mutability, aka breaking the rules, aka sometimes you just need to change stuff in global objects. So you can definitely, this is like the only breaking rules I'm going to talk about. It's not really breaking rules. Atomics. So out of the box, you get atomics from Kotlin Native, and they let you, inside of a frozen object, mutate state. There are atomics for simple values, and then there's atomic ref for objects. So back at our fun example, if you click that button, everything's going to get frozen, right? Well, if you make count an atomic int, then nobody cares. It's still going to work because you're allowed to change atomics inside of frozen objects. It really pokes a hole, like a quantum universe hole, in the memory model of Kotlin Native. By the way, if anybody's really interested in like in a super duper deep dive, we can talk about how the runtime gets built, which is all C++, which is really interesting. Well, really interesting for some anyway. That's atomic int. So this thing, atomic reference, I would argue is a somewhat more interesting and useful one. Of course, that's arbitrary, depends what you're doing. But you can keep objects inside the atomic ref. So let's say we got this, right? And the parent gets frozen on init. By the way, you don't want to freeze at the top of your object because you might not be able to assign the values during initialization. But anyway, also in parent classes, you don't want to freeze because you won't be able to init the child. So, okay, anyway, that's a fun reference. So there's an atom here, atomic reference, some data. You can change that even though the thing's frozen. This is a stately version, which is a library. If this was the atomic Kotlin Native version, you would actually need to freeze. And that brings up a good point. All of your data inside the atomic reference is also frozen. It's something you have to keep in mind. So you can't just hide mutable data in there. So my advice is don't use too many atomics. And when I say don't, I mean do whatever you want to do. But there's mechanical and sort of philosophical reasons. The current garbage collector, which is going through a rework, may have a memory leak. So if you have an like that model object, right, and it's holding on to an atom, and then the model object goes out of scope, you'd expect all that to get garbage collected. But if that atom has data that is itself cyclical, it may not get collected. In this case, it'd be fine. But it's just something that you're going to have to be aware of. That's really, you don't want to have to be aware of. So if you are doing that, you need to null them out. If you have objects that live forever, like the settings object, it doesn't matter because it never gets collected. But anyway, got to be careful with that. And philosophically, a lot of it's just like, hey, maybe you want to re-architect what you're doing rather than just making everything atomic because you don't want to re-architect the JVM stuff. Up to you, So we have this other option called worker dispatch state, which is kind of what we're leaning into now. And it's essentially mutable state kept thread local. We're sort of leveraging Kotlin Native's design for safe concurrency. So we have some thing. That thing's going to make some data. We're going to send it into this other thing, right? And what happens is we've got this broker isolate state thing, and then internally we have this state container that is intentionally unfrozen and kept mutable. The thing you passed in is frozen, but the thing that's in there, that object is not. And then on the other way out, something wants some data, it pulls it out. That state container stays immutable, and that's how we're gonna, and we just pass messages back between threads, and that's how we maintain like mutable but safe concurrent state. Isolate state thing actually would be it is frozen. Okay, sorry. Some of these slides are a little old, like seeing for the first time yesterday. Okay, so okay, that class is called isolate state, right? This is on our library stately, and it has a type that's going to be kept isolated and mutable. There's a constructor, which is a producer, which is a lambda, and it takes no arguments and returns a mutable object, right? the producer itself will get frozen. The object it returns will be run on the other thread and intentionally not frozen. In fact, we call ensure never frozen. So if you try to return that thing, it'll blow up. And there's a function called access, which takes a block, and the parameter to that block is the mutable state, and you have an optional return value. That's how you get that stuff out of it, like in that last slide, right? Let's see. Yeah, so everything gets run in that state thread, and it's able to maintain that mutable state internally, right? So we have a collection of collections that are mutable but safe to use across threads. This is pretty flexible too. So let's take this example. I want to write an extension function on this mutable map. We're going to call it check for 2. It will check for first a key, and if that exists, assigns the value to that. Otherwise, it assigns the value to the second key. Why would you do this? I have no idea. But the important point here is that that access function, that whole operation gets run on that state thread. And that means that you are automatically safe for concurrent operations on that internal object, in this case, the map. Nothing else can step in and change that in the middle of your operation. So this is like atomic, right? And you can do that without locks. And it's easy to just attach that and get that safety on existing objects. So it's kind of fun. You know, it's not as good as maybe JVMs like concurrent collections, but it's way better than a lot of other options you would have not using those things, right? And then, I mean, finally, we're not going to talk about it. You can just do whatever you want and like do Objective-C, C++, and do really, really performant and dangerous things. So you have to be very careful. But that's the ultimate, like, if somebody was like, you know, we just need the absolute in performance and we need to do this very specific thing, then you can just open up space and time and do whatever you want behind the scenes. You know, usable, but don't go crazy. So multi-platform and state. So multi-platform state, like everything we talked about now, up till now, is basically really just talking about native. It's not really talking about how do you do it in a shared context. So the first thing, freeze is native only, right? So JVM and JS don't have freeze. Actually, sidebar, you know, people are like, freeze is weird. Nobody does that. I'm like, I did a little research project. It turns out Ruby has freeze and JavaScript has freeze, although I've never heard of anyone using freeze. But it's not like this completely new crazy thing. I have to add freeze to our library in JavaScript. Anyway, you know, so the concurrency libraries you use will probably do a lot of the freezing for you if you're doing your concurrency in Kotlin, but you'll occasionally need to call it yourself. So you kind of have to like declare these things in shared code and then just let them be no ops in the other platforms, right? This is coming from Stately, but you know, I think a lot of libraries kind of do the same thing. So it's just something you kind of have to do. Most of the time you don't have to worry about it. In cases where you do, if you are different folks use Kotlin native and Kotlin multi-platform in different ways. Some do the concurrency and just get into the native platform on the main thread. A lot of larger teams tend to use Kotlin native as like a data provider. So that there's just doing database on the thing, and then you get that, and then you switch threads in Swift or whatever. In that case, you have to be careful because Kotlin's rules still apply even if you're switching threads outside of Kotlin with Kotlin objects. So you have to make sure you call freeze on everything. If you don't, like, the runtime will blow up and tell you what you did wrong. Like, it's not like it's going to just randomly do it, but you have to be aware that you're going to have to do that yourself, right? Not a huge deal, but sometimes there's some struggle with it. Completely on the other end of that, there is the fact that if you're passing Swift and Objective-C into Kotlin, they don't know what freeze is. So you can call freeze on them or not. It's not going to affect them in any way. But then you have to be sort of aware of the concurrency repercussions. Like Swift and Objective-C let you do whatever you want in any thread, just like the JVM. So again, not a huge issue, but you're not going to get any concurrency safety with those objects just because they're running in Kotlin native. Okay, so concurrency libraries, right? So the big topic is coroutines. And up until recently, the only option on Kotlin native for coroutines was single threaded. And a lot of people find that to be weird. What do you mean? There's, you know, coroutines is threading. And it's like part of coroutines is threading. it still makes sense, right? So like, for example, this is something that you have to get your head around. KTOR native, you call it on the main thread, and it looks like you're calling the network on the main thread, but you're not. It's suspending once you call, and all the networking happens on another thread, and then it'll resume and come back on the main thread. Obviously, if you have a huge JSON response and you parse that in the main thread, that might be problematic. But in general, it's not, right? And we've all been waiting forever for multi-threaded coroutines. So November last year, as I was giving preparing for this talk, this draft of multi-threaded coroutines dropped, and I was very excited. And I had to change like the last third of the talk, yada yada yada. And it's June, and that's still open, right? So what's going on? It's kind of a long story, but without getting into super detail, going back to that garbage collector for atomics, there's still that's part of why they're working this out, because there's sort of edge cases where you could wind up with some memory leaks. So there are going to be two branches going forward until this gets resolved. One is the main single threaded, and the other one is the multi-threaded, and they're going to be doing releases for both. We use the multi-threaded one. One of the pieces of content I'm going to have to do soon is how do you do that and avoid situations where you might have memory leaks? And I'm still doing research on that. It's kind of up to you. You can not use the multi-threaded coroutines branch, but we do, and it works. You just have to be aware of what's going on. Unfortunate. I wish it would merge soon, but it's going to be a little later this year, hopefully. Cross fingers. So switching threads in coroutines is a lot like how you do it in the JVM, right? Like there's with context or equivalence, you give it a different thread context. The data passed in or captured is frozen, and the data returned is frozen. It's the same way with that background. I think I forgot to mention when I did the background thread, the spoiler is that every library in Kotlin native that does pass things between threads is going to use the same model, which is freeze the block and everything it touches and freeze the return. So same thing with multi-threaded coroutines, right? So how that works with our old example background, if we switch that to coroutines, this is a suspend function. We give it a different worker dispatcher that is a different thread, right? And we call with context, and then now that freezes everything just like it used to, right? No different, no magic. Just that's how it works. The other, subtle differences, we're gonna return a new version of some data, some more data, and print it out, right? So that is data being generated in the background thread, and then the foreground thread has suspended at this point. Now it's going to resume. It gets that data and it prints it out. It is frozen. That's how that works. That's like its own whole talk, so I couldn't get too deep on that. But we're using it. It totally works, right? So flow, channel, all that stuff's there. It's all freezable. Back to our model here. In this case, the database is SQLite using flow coming from a different thread and passing that data up when it changes. So a lot of the architectural components that you would be used to are here. Anything that's missing is we're sort of trying to urge the community to rapidly manufacture it. It's kind of what I do all day. So cool. New for 1.4 is iOS suspend function. So previously, if you had a suspend function, it would not get exported to the Objective-C interface for your iOS stuff because iOS doesn't know about suspending yet. We'll see how Swift navigates that. But now you can do a suspend function and it'll be exposed as a function with like 2 callbacks, success and fail, I think. We haven't tried it yet. We ought to be kind of doing this stuff. Like we actually have a bridge that allows you to go directly into RX Swift. So this isn't like, a lot of people are like, oh, finally we can do this. It's like you could do this before. You had to do a little more manual work. But looking forward to see how that goes, and everyone's pretty excited. So Stately. Stately is our library. I've mentioned it a few times. Back in December, I was saying, hey, we're probably going to deprecate this because Atomic Food is a lot of the stuff from JetBrains, and we'll just keep the collections. But turns out I found out that while Atomic Food is public, it's not necessarily promoted by JetBrains. It's kind of an internal thing. So I had some deep exploration and decided that we're actually Stately is not only staying around, but we're doing a version 1, and we're adding a bunch of stuff to it and making it smarter. So The modules are stately common, and that's like the common definitions of freeze and ensure never frozen. I split that out because what was happening was we had everything in like one big module, and people would copy paste that out because all they wanted was to be able to call freeze from common code, right? So that's now in common. Stately concurrency is atomic reference and all that stuff. Locks, you know I said that you're not going to manage concurrency, but you occasionally will need a lock for something. Just FYI. And then there's collections, which is not quite deprecated as like this, I wouldn't recommend it. It's a bunch of collections implemented in atomic reference. There are cases where it might be useful. So we're not going to get rid of it. We'll keep it around. And then, of course, the new thing, stately isolate, which is the raw module, then the collections module, which I was talking about. This is alpha because it's still going to be changing pretty fast. So if you want to do, concurrent mutability, please try this out. Give us feedback. We definitely like to hear anything about it. I also owe a big blog post about that, hopefully in a week and a half-ish. So another library that's very important, coroutine worker. This is before there was multi-threaded coroutines. And currently, if you don't want to use multi-threaded coroutines because you're concerned about its state, coroutine worker is from Ben, Autodesk. It's like a source compatible version of calling with context and stuff like that using workers that will allow you to have the coroutines basic support for crossing threads. There's a lot of stuff that's not there. Like, you can't use just flow out of the box. But if it does what you need, like I definitely know several projects in production that are happily using this. So definitely check it out. And if you're not really a coroutines person at all, there's a really good RX implementation. I've tested it. We don't really use it in production, but I'm informed that quite a few people really love it. So you should definitely check that out because it's a massive amount of work that came out. I was really surprised, but it's humming along and being kept updated. So that's pretty great. Okay, next steps. So what do you do if you want to get started? I threw a bunch of stuff at you in the slides, right? And there's only so much you're going to pick up. But this hands-on that I just published is a practice of all the basic concepts that I talked about here. And you just kind of run through it and you can poke around and change stuff and it should become a little easier to pick up just doing that, right? I have a blog series that was written after Kotlin Conf. It was like, let me try to present this in a way that makes sense, which is sort of like the parallel thing of this talk. So you can go read that for, I can do a little bit of sidebars in there that I don't have time for in conference talk. And then on my Dev2 account, there's a bunch of other stuff that's maybe, I wouldn't really recommend, but you can check it out. Like, how do you, move state between threads? What does that mean? Like, live state, that kind of stuff. And then if you want to go way back machine, I had this series that talks about worker and does all this stuff that I wouldn't necessarily talk about now, but it's certainly interesting. And over time, I really try to trim down my blog post writing, but the further back you go, my blog post writing, I have a lot of sidebars. You may or may not find them humorous. Okay, JetBrains links. So these are the first two of the official docs from the team about these concepts, and they're good for like a detailed read. Last one's a talk by Nikolai from 2018's Kotlin Conf, which I wouldn't watch as an intro, but if you want to really get some sense of what's going on under the hood or why they made decisions that they made, it's really good to check out. Finally, check out CampKit. This is, we built, there's hundreds of commits to build a template project, but it's really like Flutter and React Native. If you go search out getting started, they both have like the 5-10 minute, like from nothing to a running app. And if you do that for Kotlin Native, you could be hours in trying to fight different Gradle configs. We wanted the 10-minute from nothing to your editing code experience. That's what CampKit is with associated documents. And we're going to maintain that. It's just for native mobile at this point, but we're going to maintain that indefinitely until, whatever. And we keep adding to that. We just added Swift UI and we're changing the architecture to a more modern thought process. And that's where that at. 40 minutes exactly. Thank you. That's my talk. It's really weird not being in front of a live audience sometimes. Like, there's no feedback whatsoever. Cool. So that's that. Let me see if I can join chat. Let's see. Okay, I think this is where chat's happening. Let's see. My favorite issues, coroutines. Bridge to RX Swift. It can be. It could be. We haven't made a library out of it yet, but I can just, Russell Wolf, who made multi-platform settings, is on our team, and he's kind of the one working on that. So I'll just tell him to put out a sample, and then we'll talk. I'm not sure if we're gonna do a live thing. I'm an open source project in that we're discussing, but I could definitely share a sample. It's kind of cool. I think the issue is like, if you call on the main thread, everything works fine. If you're listening from a background thread, we're still sort of sorting out the implications of that. So there's kind of two philosophies. Like, you either manage all of your threading in Kotlin and everything in the native platform is main thread, or you don't. But if you try to go in between, it can get complicated. Let's see, stream. Great, thanks. Would be great. Okay, cool. If you're on the Kotlin Slack, join the Kotlin Slack. I forgot that stuff. Just ping me. Like, I'm on there all day, or Twitter or whatever. Let's see. Question. Runtime error looks cool. I don't know. Most people don't agree. The IDEA plugin. If you want to see an awesome IDEA plugin, actually, there was a talk. It's from Amanda from 47 Degrees, and they really like icons and everything. I'm like, man, I felt shamed. That's kind of why I stopped. But yeah, check it. It's a totally different plugin. It has nothing to do with it. But it was amazing. Yeah. So I kind of wanted to polish it too. We might put it out. I guess the issue is it's useful for learning. It's not useful for. It's not useful for me mostly. Like I'll be like, if I do something bad, I'm like, oh right, of course. But if you're new, it's useful. So it's the design of it really needs to be more of a learning plugin. Like, it should be like, hey, you should do this, and then like take you to a web page that explains it. And so that's kind of the state we were at. And then I was talking to JetBrains about it, and they're maybe going to put some stuff into IntelliJ. So it's like, well, I want to see what they're going to do, and yada yada. Life moved on, and then the pandemic. So, any other questions? Oh, proposal for Swift to implement freeze. You mean Swift objects, or I'm trying to understand. Freeze is, if you mean Swift objects, it would be extraordinarily difficult because freeze happens like very under the hood in the runtime in Kotlin Native. I don't know who would want this talk, but going into the runtime of Kotlin Native is kind of super interesting. Like I started Native in 2017, and like at the time, you kind of had to build Kotlin Native just to be able to use it because it was like really, really new. So I had this somewhat unique experience of the platform. So like when you see an error and you're like, "What's that?" I'm like, "Oh, that's that C++ file, and it's because of this, right?" So Swift would kind of need to do that, but their whole world is tackling concurrency differently. Like one of the big issues, if you're trying to convince iOS people to use Kotlin Native, is there are no structs, right? And structs is a big deal. Like if you change a struct, it actually does a copy on write, and that's kind of how they're managing concurrency in that world in the safe way without doing freeze and stuff like that. And there's no enums with associated values and other stuff that Swift developers are used to, but structs is kind of a big one, and like the way that they're managing concurrency is like sort of in the middle. I don't know. So I don't know. All right, do we have any other questions? I feel like no. Let me just scroll. Okay, cool. Well, I guess we're done. So everyone have a great day.